Good day, everyone. Welcome to my channel. This is a really amazing day, and thank you very much for looking to my channel. So basically, my channel basically speaks about like major things that has to do with renewable energy, and speaks about the depth of renewable energy. I would urge you to not really pay attention to surroundings because I wanted to start making YouTube videos early on, like 2 years back, but I really was not because of my surroundings and things like that. So I'm not going to use my surroundings as an excuse. I'm still going to do what I need to do and like fast forward from there. Yeah, thank you so much. So welcome to my channel. Today I'm going to be basically exploring a very unique aspect of power generation. Now there's a big question: is is nuclear energy renewable? When I say nuclear energy, I mean nuclear fusion. But before we get into the whole concept, my name is Adeze Osakwe. Welcome to my channel, and I really hope you enjoy my channel. I want you to basically look at things. I want you to basically ask questions and maybe make some comments if you want me to, like, based on what you would want me to, speak about next time. And you know the drill. Please, I want you to like, share, subscribe to my channel, and see you next time. So let's get into the video. So I'm making my videos 1% better each time. So the edit is basically going to come much later. Please forgive my surroundings and the noise, if you can hear like a lot of noise below. But let's basically go on. So the question is nuclear energy renewable or not? And basically, what is the product of it? Like, if you can get a product from that source of energy, what exactly would it be and how would it be? So let's get right into it, right? So the first thing is this: when it comes to nuclear energy, there are different types of nuclear energy. Not different types, basically two that are, will I say, that are quite used in the concept of, like say, energy and things like that. So the very two or the very unique ones is nuclear fission and nuclear fusion. So what exactly is nuclear fission? Now there is something unique about nuclear fission that I basically really love, which is just the fact that you're tearing apart things. It's like when people will tell you that it's very difficult to basically build something and it's easier to take it apart. That's exactly what nuclear fission is. It takes whatever is being put together apart. It just takes it apart. It basically uses uranium as its very active material, in which after like some kind of activation, then it basically like just start like popping up and separating and causing a lot of havoc. And when it does that, there's a lot of energy that's basically gotten from that. But the energy is actually quite small, and the product of it is actually quite bad. Now, if you're getting a little bit of energy and you're having a lot of disadvantages, why then will you continue with it? So, what exactly is the advantage of nuclear fusion, or yeah, of nuclear fission? The disadvantage of nuclear fission is that it produces a lot of reactive materials, produces a lot of radioactive waste. Now, the problem of radioactive waste is not just the fact that it's being produced from nuclear fission; it's how to store it. For instance, you're looking at radioactive waste in the concept of, if you're looking at waste in a very retrospective concept, where, for instance, you can take animal waste and impute it to a farm, and then you'll be able to get like your products from there, crops from there, which is actually good waste because you're taking the waste and you're utilizing it into something like biodegradable waste, But that of nuclear fission is not. And as a result, how exactly does this even work, and why exactly does this kind of biodegradable waste really like doesn't really help like a lot of things? Now I'm going to be looking at like the major aspects of this biodegradable waste. One major thing of the biodegradable not non biodegradable waste, please, yes, is that the first thing is that it's actually very radioactive because of materials like uranium is very radioactive material. So the product of this, that's the waste of this particular fission or this particular energy technique, is actually going to be radioactive. Now the problem of this radioactive waste is that the waste being produced cannot be effectively used in any other aspect. That is, it is so bad that even to store it, it basically affects anyone who stands 10 feet from it. So there was a recent study, I think 2021, 2022, by I think the Parisians, that's French. What they decided to do was that they wanted to basically dig. I think they got a very like a very large land, like there is like up to, I don't know, thousands of acres of land, hundreds of thousands of acres of land, and then their idea was to basically dig underground and keep this particular radioactive materials underground because there's literally nothing to do with it. There is no way you can use it for something amazing. You can't use it for anything. It's just there and it's really bad. So how exactly do you work with that, right? So now let's get into nuclear yeah, so that's the problem of nuclear fission, about the waste and things like that. So let's get into nuclear fusion, and let's see why nuclear fusion is even called a renewable energy. Like, is it actually meant to be called renewable energy? Now, the first time we spoke about nuclear, I think at the beginning of this video, we spoke about basically nuclear fission, and nuclear fission is very like putting things apart, taking things apart. Now, nuclear fusion is putting things together. Like, it focuses on what kind of materials or what kind of chemicals can I put together what elements can I put together and then get a massive energy from it. So the basic element of nuclear fusion is deuterium and tritium, whereby you have like these two elements come together as isotopes of hydrogen come together, and then when they come together at a very high heat, which is basically hotter than the surface of the sun, which is about 100 million degrees, because the surface of the sun is about 10 million degrees. Yeah, so now they need to come together under a particular kind of temperature, which is about 100 million degrees, and it's very, very weird because if we have such heat, it can basically cause damages, right? So when they come together, then there is this huge, massive energy that is basically expelled from it. Please, I would urge you once again to like take your mind away from the noise, because it's gonna get like quite noisy like really soon. There's like a kind of bike passing by. But let's get into it, right? So nuclear fusion is basically the things coming together, right? So where you have again, sorry for that, right? So where you have deuterium and tritium come together at high temperature, and then they expel a lot of energy. Now, why is this particular concept even used or even preferred to fission? Is because using this kind of energy, what actually happens is that when you use nuclear fusion, the energy produced is actually 10 times more than that of nuclear fission. So which means it's actually very, very good. Now, does this even produce any waste? Because you're using weird concept and weird elements that actually has a very unique physical roots, such that in the sun, every second about 700 million tons of hydrogen is being converted into 690 something 90 or 90 96 million tons of helium, which is basically the whole process of nuclear fusion, right? So which means that nuclear fusion is even like it has been in existence before the actual technology was found or want to be used and things like that. That is why nuclear fusion is basically one of the what is called the holy grail of electricity, which is very, very cool, right? So now let's look at the product of nuclear fusion. Nuclear fusion produces helium as a byproduct, which is even better than having radioactive waste as a byproduct that cannot be degradable. Instead, helium can basically solve the problem of our climate deterioration, such that when helium is produced, you can actually basically just release it into the atmosphere to heal the earth. Because if you're looking at climate change, which I'm going to talk about in a very later video, you're going to see that climate change is actually born as a result of, I like to call it injuries to the atmosphere, to the ozone layers, because of heat, carbon emissions and things like that. So in order to basically work on these things, you need to heal the earth back. So how do you heal the earth better? You heal it through basically using helium, which is actually a byproduct of nuclear fusion. Now, recently, that I think I mentioned in a previous video that there was a kind of event that was hosted that spoke about one major thing that has to do with the production of hydrogen, in which Nigeria basically worked basically on blue hydrogen being generated from the gas that it already has. Now, the hydrogen being produced from nuclear fusion is known as pink hydrogen. It's actually very much renewable, but it's good. But now, what exactly is the problem of nuclear fusion or of nuclear energy in terms of like having it produced 10 times better? It is that there is no there has been ongoing research by Helion, and they're really they are literally an amazing company which I basically follow because they're doing amazing work. And so basically Helium has basically gone further in the aspect on the research of nuclear fusion, and they've been able to ascertain that you can basically work on these things with time, and over the years they've been able to research over like 8 years plus right now, or over a decade, and they've been able to ascertain that there is a way to basically produce this energy, because the concept of basically using nuclear fusion is that you can't really get as much energy out as you put in. This was some 4 years ago, but right now you can basically get equal energy in out that you put in, which is actually very much huge. It's a very huge advancement in the field of nuclear fusion. So I basically did the research. If you have questions on my research, please let me know. I did a research on how you can basically improve this technology, because I'm talking about the depth of nuclear fusion. Now I know for sure that there is more than one way to basically get to a particular result before even without having to go through like the normal process. For instance, I think a few decades ago, a lot of students were very much involved in studying using basically rereading, making notes and highlights, which are basically proven to be less effective. And instead of using, you can basically study more using active recall, space repetition, and using like the spider diagram and things like that, which is very amazing. So now this is like a huge difference, which is basically not even like the proper way of studying, not what a lot of students basically imbibe. And I think more than half of the world population of students still are yet to basically get into the fullness of this idea and basically using to study in schools. So now I just basically had to go through like a detour. Coming back to the whole thing on nuclear fusion, there's actually a very amazing way to basically achieve this result. But to basically achieve this result, you need one particular thing, which is using a very different technique. And the technique you have to use basically here is, if you have to use heat to basically produce nuclear fusion, then how exactly are you going to produce the same energy using a different source? Instead of using heat, why don't you use something weird like speed? Because speed is relative. If you're going to be looking at the Doppler's effect, you can use that to the advantage, right? So in the next few videos, I'm going to be explaining better on this Doppler's effect and how this is being used. But I'm going to say my goodbyes here. Thank you so much and have an amazing day. Please like, subscribe, and share. Thank you. Bye.